Well, the department is amazing. No matter what you want to do in astronomy, you can do it here. We're a center for SETI, we have an exoplanet center, we have a wide range of instrumentation groups. I have never been in another astronomy department that has such a wide range of things that you can study, all the way from the very basics up to the big open ideas in cosmology and theoretical astrophysics. I'm actually on the instrumentation side of the coin. So you imagine an astronomer looks up into the night sky, comes up with some big theory. I actually make it so that those astronomers can see things. I build the instruments that help them with that thing. And so what we do in this lab is we design X-ray spectrometers with state-of-the-art technology that NASA is reluctant to put into billion-dollar missions. NASA doesn't like risk. And so one of our goals is to take these brand new technologies, put them into space for about 20 minutes, do an observation of something cool. So the high energy universe is what we're interested in, supernova remnants, binary star systems. And then we prove that that technology can work. We improve what's called the technology readiness level of the technology, which makes it so that makes it more likely to be selected on future big orbital missions. So a big part of what we do is technology development, but everything that we do, we make sure that we have an interesting science goal. So space missions are becoming more and more bespoke. With CubeSats, with small sats, with suborbital rockets, you're able to target very specific things. So we typically look at temperature of supernova remnants by looking at ionization levels in oxygen, which requires large field of views and high resolution, which you can't do with any of the major flagships these days. And so we are able to develop an instrument that can do that. We're able to take lots of risks, we're relatively low cost, and we can put these things in space. The other cool thing is we can do this on relatively short timescales, so it fits really nicely into the scope of a graduate student study. So they can very much cradle to grave these things. So you can be involved in the proposal at the start, design the instrument, build it up in 3D CAD land, work with machinists to get it made, build it, test it, integrate it with NASA, and launch it. And all of that can fit within the scope of a PhD style project. I have felt really included in everything that we've been doing since we came to Penn State. The previous head of the department, the current head of the department, very keen to get everyone involved, to break down those barriers between faculty, graduate and undergraduate, attempting to make it more of an inclusive environment, which is something that's very hard to do, but they're definitely doing everything they can in Penn State astronomy to make that the case. And so I've always felt very welcome. Hey, you want to build something that's going to go into space? That's what we do. So if you're interested in instrumentation at all, come along, come down, see what we do. We can get you involved if you want to design an instrument. If you have a very specific science question that you're interested in, maybe we could write a proposal together that could target that in a short space flight on one of these suborbital rockets. If you're interested in instrument design, instrumentation as a whole, that is what we do. And if you want to be involved in something that launches into space, you get your own data and you're able to answer your own very specific science question, our lab is the place to be.